Hello everyone, this is Devinder Kaur and you all are welcome to the Enlightened Room. Today we will discuss about energy, forms of energy, what is kinetic energy and its expression. You can say the mathematical expression. So let's get started. As in layman language, we say that energy is needed to do some sort of work, whether it is a physical work, it is some mental work, whether I'm teaching. If I'm teaching you, that means I have some energy to do this work. Okay, so whatever the kind of work you are doing, you need the energy to do. So simply in the language of physics, we also say that energy is the ability to do work. If any kind of work is done, that means there is the need of some sort of energy to do that work. Okay, so we can simply say that whatever the work you have done is the amount of energy you have used in that work, right? So simply if we say that you have applied some force on an object and it has moved some distance, so work is done. So that means you have applied that much amount of energy to do that work, to apply the force so that the object has moved. Okay, so this is simply about the energy. Now there are various forms of energy. You can say there is heat energy, there is thermal energy, there is water energy, there is wind energy, electrical energy, charge. The charges also possess the energy in the form of electrostatic energy. Okay, there is gravitational energy and many more. The more you can think about, even you are watching this video, you have some room, you have some light in your room, as this room also has some light, right? So light is also a form of energy. Okay, so we are able to see with the help of light, and that light is also a form of energy. So energy is, you can say, everywhere. Even the objects which are at rest, they are at some height, those objects also possess some sort of energy, which we will discuss in the upcoming videos. So today in this video we will simply discuss about the kinetic energy. Okay, so let's move on to this topic. So before moving to kinetic energy, I would like to tell you that kinetic energy is a form of energy which is possessed by the moving bodies. So whenever you see a moving body, whether it is having some kind of rotational motion, it is having some sort of sliding motion, okay, of course if it is moving, it has some energy. That means it has some rotational energy, it has some sliding energy, whatever you want to say about it. Okay, that moving object is possessing some kinetic energy. Whether you are riding your bicycle and you has some kinetic energy. If you are riding a car, you along with the car is having a kinetic energy. Okay, so kinetic energy is for the bodies or objects which are in motion. Okay, now we have an expression, a mathematical expression for kinetic energy. For that we will consider an object. Okay, so we have this ball here on the ground and you have applied some force on this ball from this side, and this ball started moving with some initial velocity, and you are simply continuously applying that force, and at this point you needed to find what was its what distance this object covered. Okay, so we have this ball here now and the force has been applied on it, and this body or object is possessing the final energy now. Now since we take the distance from the centers, I would like to take the distance from here up to here. Okay, so we need to find what distance this object has moved after applying the force on it, and the object had attained some velocity. Now simply to determine the distance, we had some equations of motion. Well, why am I using the equation of motion here? Because the object has been in the motion, right? If the object has been in the motion, that means we can simply apply the equations of motion for this, right? So we had three equations of motion, which from which one of them is v is equals to u plus at. The second one is s is equals to ut plus 1 half at squared, and the third one is v square minus u square equals to 2as. So since we are not given any sort of time here, so I'm not gonna use this one, and first one is is for no use to us because since the distance is not given here. So we will use this, simply use the third one. Now we will use this equation. So I'm gonna simply use it from here. I need the distance now. So I will take v square minus u squared over 2a equals to s. So here I have found the distance. Okay, so I'm gonna name this equation as equation number 1. Now we also need to find the force, how much force has been applied on this object. Since this object is having some mass, every object in this universe has some sort of mass because it is occupying their space, it has matter in them, right? So for this I would like to have the Newton's second law of motion, which states that force applied on any object having mass accelerates, right? It would move. So we have also got the force here, and I will name it as equation number 2. Since in the beginning of this video I had told you whatever the work we have done is the amount of energy we have used. So if I use the formula of work done, which is W equals F times S, I can determine the energy, or I can find out the energy. Okay, so W equals, the value of force is M times A, and S is V squared minus U squared over 2A. Okay, so A and A here will cancel each other, and I will be left out with work done equals M times V squared over 2 minus M times U square over 2, and I can simply write it as energy because the amount of work done is the amount of energy consumed or used by the body. Okay, now if we simply say that the object which was previously at rest, okay, it did not had some sort of initial velocity here, that means initial velocity here is 0. If that object has initial velocity 0, that means object is at rest. So I can simply say that it is M times V squared over 2, as this term will become 0. 0 times M, 0 and 0.2 is also 0. Okay, so I have the formula for energy, but which kind of energy? It is the kinetic energy. So I can write E sub k here, E sub k here, which is a denotation for the kinetic energy. So today in this video we have some discussion about energy, the forms of energy, kinetic energy and its mathematical expression. How do we deduce this formula by assuming a body and by assuming how much force has been applied on the body. Okay, so this is up for today's video. If you found my video useful, do share it with your friends, do like my video, comment on my video and subscribe to my channel if you haven't subscribed to my channel yet. Thank you for watching.